So I'm going to be going through Newton's second law equation, Newton's second law problem. This is the problem already worked out. So this problem is based off of Newton's law, and it states, and the problem is that um, there's an incline with friction, and there's a 50 kilogram mass placed on an incline that makes an angle of 30 degrees with respect to the horizontal. The coefficient of friction between the mass and the incline is zero point 0.2, and I am trying to find the acceleration. So, like I said, this is based off of Newton's second law, and that means the law is a force equals mass over acceleration. But since we're trying to find the acceleration, we solve for A. That's how we get acceleration equals force over mass. But the force is actually going to be F net. So this is an indication of the problem. 30-degree angle, 50 kilogram mass, sliding down, and we have a friction that's forcing this that's going against the mass. So we know that anything directly making contact straight down has mass times gravity. But this is not a straight plane; it's actually on an angle, moving. So we do the horizontal and perpendicular components, which is the mg sine here and the mg cosine here, and that pretty much cancels out this mass times gravity right here in the center. So I can show that. That's no longer really needed. And since we have a friction force, we must remember that our friction force is equal to mu k times our normal force. So since this mass times gravity here is like no longer needed, our normal force is, well, the box on the plane is pretty much weight against the surface. So we must have an equal force pushing back against it, which is the normal force. And the normal force is going to be that equal to this mg cosine theta. So that's why over here, our friction force being mu times normal force is equal to mu mu k mg cosine. We just replaced mg cosine, the n with normal force with the mg cosine. So after, and of course I found my f of x, which is sine theta, sine 30, and my f of y, which is cosine theta, cosine 30. And this is just a free body diagram of what's happening right here. So Newton's second law, we're trying to find acceleration. Acceleration, and our f of net is mg sine minus mg cosine theta mu over mass. Then we do algebraic function, and we pretty much pull the mg out from here and here, pull it out, and we have sine theta minus cosine mu over mass. The mass is time canceled out, giving us gravity times sine theta minus cosine theta times mu. And then we pretty much plug in the values weight of gravity times sine 30 minus cosine 30 times friction force. And sine 30 equals 0.5, cosine 30 equals 0.866 times 0.2. We multiply these two first to get that, and we just bring that down, and then we subtract that. We subtract that from that, then times that to get that, and that is our acceleration.